So inspired from the photon picture of electromagnetic radiation, Einstein photon picture of electromagnetic radiation, and the experimental evidences of the line spectrum of atom, the Bohr proposes the first semi-quantum model of the atom. So he gave three postulates for in his model. So the first postulate was like in an hydrogen atom, electron revolves in a certain stable orbits. So there are only some discrete orbits around the nucleus in which electron revolves, and in that discrete orbit or the stable orbit, the emission of radiation doesn't take place. There is no in that orbit, electron doesn't radiate energy. So those are a stable orbit. So in his second postulate, he stated that only those orbit exist uh, for which the angular momentum of the electron is integral multiple of h by 2 pi or h cross. In the third postulate, he said like if a fourth electron transit from a high energy level, like from higher energy level E2 to a lower energy level E1, then there is emission of a photon having energy E2 minus E1. So h nu equals to E2 minus E1. So nu is equals to E2 minus E1 divided by h. So that is the frequency of photon that will be released when this is a transition from higher energy level to lower energy level. So, using the classical physics and his quantization principle, he proposed that for a hydrogen atom, the radius of nth orbit is given by 0.53 into n square angstrom, where n is a principal quantum number taking value positive integer value. So one n can be 1, 2, 3, 4, 5 up to infinity, and the total energy of the electron in that particular principal orbit is given by minus 13.6 n square electron volt. So energy of the electron is inversely proportional to the principal quantum number, square of principal quantum number, and radius is uh, proportional to n square of the principal quantum number, like square of principal quantum number. So what is the ground state and excited state? So n equals to 1. The first orbit is said to be a ground state, and the ground state energy is minus 13.61 electron volt. If you put n equal to 1, you will get energy of the first orbit to be minus 13.6 electron volt, and the radius of that first orbit is 0.53 angstrom. So the orbits which is having principal quantum number greater than 1 are said to be the excited states. So any state having principal quantum number greater than 1 are excited states, and if atoms are excited to these higher state by a collision, so the electrons can be excited to these higher state. If suppose electron absorbs a photon of suitable energy, then it may excite to higher energy level. Or if two atoms have a collision, then by collision they may happen that electron may excite to higher energy level. So collision and by absorption of suitable photon of suitable frequency, uh, the excitation can be happen in an atom. So now coming to limitation of Bohr's model. So Bohr's model was applicable only to hydrogen atom, the atom having one electron. So just applicable to hydrogen or hydrogenic atoms. And the second was it cannot be extended a two electron system. So we cannot apply the Bohr's model to even to a two electron atoms such as helium. And also it was able to explain the line spectrum, but it was failed to explain the difference in intensities. Like some frequencies were having higher intensities, and was some wavelengths or frequency were having low intensity. So there was a change in intensity of different frequencies. So it wasn't able to explain that why this relative change in intensities of different frequencies. So by that time, many of the scientists were like, we have the evidences like uh, the light was showing both particle and wave behavior. So scientists were very much convinced with the dual nature of radiation. So light shows both particle and wave behavior. So inspired from the this behavior, so De Broglie had proposed that nature loves symmetry. So since radiation, the light particle, the light which is showing both dual nature, so it must be that the the matter itself should also show the wave behavior. So De Broglie in his PhD thesis proposed that uh, a particle wave is associated with a moving particle, which whose wavelength is given by h by mv, where h we all know is a Planck's constant, and m is the mass of the particle, and v is the velocity with which particle is moving. So this was his PhD thesis, and it was proved to be right by some certain experiment done after his hypothesis. So this hypothesis also helped in understanding the Bohr's quantization rule. So we can understand the Bohr's quantization rule as follows. So only those exist for whose uh, the length of circumference is an integral multiple of the wavelength electron particle wavelength. So 2 pi r is the radius of the nth orbit must be equals to the n times the principal quantum number into the wavelength of the electron into the electron particle wavelength. So this is the pictorial representation. Like you can see, the electron is forming a standing wave in his orbit. So that number of standing waves should be the length of the total circular path. 2 pi r must be equals to the the wavelengths that standing wavelengths that are being formed in that orbit. So at last, let me thanks. So thanks for watching.